So the winner, so Christopher, could you please start loading your slides? And we are really excited to hear more about what has been done. So congratulations.
Yeah, thank you. Can you hear me?
Yes. Yeah, we can hear you.
Thank you very much. Shall I share the screen, right?
Yes, please.
You see it? Yes. Can you see my slide?
Yeah, I can see it. Yeah. Go ahead.
Okay, cool. Yes. Okay, so thank you very much. Yeah, I love this challenge. I think it's very interesting. So I'm going to present how I achieved these results. I wanted to do a lot more. I think I had many ideas in mind, but they did not work in practice. So I will share my thoughts, and I hope in the future also people will be able to implement these kind of ideas somehow. So the first thing is about the PDF. It's about reading the PDF, and so reading the paragraphs. So normally I think I should use the term block rather than paragraph, because I distinguish a paragraph from a header, from a title. And the block could be either a paragraph or a title, but sometimes I'm saying a paragraph as well for headers. But so the main there is a first challenge in reading the PDF, because the PDF only contains a stream of characters, and so it doesn't give us the words, the spaces. It doesn't give us the lines, the blocks. It doesn't the reading order between the blocks, in which order we should read the document, in particular when it's multi-column. And also then, how do we summarize, aggregate the formatting information we have at the char level or at a span level to a block level or to a higher level? Okay, so to solve to solve this, I have been testing many different technologies, and at the end I was happy with Habi software. So I used their technology because they have a good layout analysis and reading order technology. Okay, so there are just a few mistakes. It's very difficult to, for example, sometimes there is a section in the middle of a two-column page, and it's very difficult for the technologies to understand if everything is on one column, is in two columns on the full page, of if it should stop so at the middle of the page and go to the top. So the reading order is a real challenge. And in particular, so at the end for your metric, because the metric is very sensitive to the order in which you read the titles, because if you miss early titles, you will also miss the next ones in the matching. Not necessarily. Also there is also a problem at the level, at the depth of the title, but and so there is also a problem at the matching step. So reading order is very important. And the second thing that is very important, I think, is when I was computing the style features or the format features for a block, so for a paragraph or for a line. So for example, when I read at this line where I've been written no style feature of averaging, so you see it's written in red, bold, underlined. So but the thing is, most of the paragraph is most of this block, with use of most common feature in the block and the line. Most of this block is also in the background style, so the most common style. So if you do an average, for example, it doesn't mean it doesn't mean much. If you say, for example, you saw, for example, I don't know how many, 20 characters are in bold and 80 characters are not in bold, so you do an average, so you get something like 0.8 boldness for the boldness feature. And I think it does not mean much. I think it's more interesting, for example, when there is a font size of 12 or a font size of 11. It's like 11 is like a key. It's not a real number for me. It's also like a key. It looks like a key. And this key will enable me to cluster together some blocks with the same features. So I think it's better to work with kind of histograms for the feature values that are possible for example, for all style attributes. So when I extract, so with ABI, so I will extract the page number, the page height, page width. I will extract also the number of lines per paragraph, per block. I will extract the text. So I'm not using the space, the line spacing, the space between lines. So I have put it here because I think I should use it. I use it for styling, so what I call style, so font name, font color, font weight, underline, italics, font size. And I do the same for the first line, okay? And the first line, for me, when I go back, for example, on the block, no style feature averaging, use of most common feature in the block, I would consider the first line as no style feature averaging, you know? So it's not necessarily exactly the first line. It's the first run on the first line, you know. And I take this text because this will be could be the header, and I will take again the formatting attributes for the first line. So in this case, it will be red. It will be bold, underlined. While the block, so the block will be the full block will be in the most common feature for the background, so that will be not bold, black, and not underlined. So then after the block extraction, so I will compute some continuous and categorical features. So for styling, it's only for me categorical features. I'm just adding to the previous one the all caps Boolean. So it's a bit different from all other styling because all caps come from the text, while all other attributes come from the formatting. And I have the position feature. I'm not using everything. I'm just using the abscissa of the block of the first line, the indentation, the width. I'm trying not to use everything because I need to be as much invariant as possible. Okay, so yes, the font size is in pixel, so it's important, converted into pixel. So so one aspect of my approach is the idea of enumeration. So enumerations, you understand it very well when it's a numbered enumeration, so 1, 2, 3, 4, for example. In an enumeration of titles, of headers, you will have the same styling, okay, usually. You have the same styling, same number format, sometimes number continuity, sometimes the number is constant. You also have the same indentation or abscissa. So they share some styling and some position features, okay? So why do I speak about enumeration? It's because, on the contrary, a header that does not belong to an enumeration, so I would call a kind of cluster of headers, a lonely header is very ambiguous for humans. And when I looked at the data, for example, one could see that on one annotation you will have considered the title prospectus as a title, and in another one you won't have. So, and the problem with this is that it has a consequence first on the depth, because the depth of the level is an integer, an absolute integer, so in this absolute level, so everything downward will be wrong, you know, in terms of depth. and also, so there is ambiguity for the humans. So if I look, for example, at this scientific paper, you see abstract is a title. It's a lonely header. For me, I call it a lonely header. It's my nomenclature. Contrary to introductions that belongs to an enumeration, so a kind of cluster of titles that share same attributes. So why I'm saying this, it's because enumerations are very robust. We can say every human will agree on them, I think, mostly. They can be very recognized, while lonely headers, in fact, it's any block of text that has an emphasis, I would say. Sometimes the abstract is the first line, what I call the first line of the block. And it could be considered as a kind of title, as a kind of entry point in the tree structure. So for me, I call this tree structure the kind of document object model, where you could have paragraphs at every level in the tree. And the table of content is, for me, only the headers. So the most important information and structure of the document. Table of content does not contain any paragraphs. While for me, the paragraphs in the tree structure, like in HTML, are at a kind of level in the HTML tree, right? So these are the two concepts. But this is very important to see, because I wanted to make that work. So I was not necessarily perfect to implement this, but I inspired a lot how I build the features. Yes, so table of content as well is not necessarily a tree, I would say, because in the example I've shown here, for example, you have 1, 2, 3 on the left, 1, 2, 2, 3, 4, and then 1, 2, 3, 4 again. So you could have multiple enumerations of title in a document. Nothing is against this. At a higher level of headers, it could be, for example, 2 contracts in the same PDF. We could have two presentations in the same document. It's not impossible to have a document, a multi-document PDF, for example, in which you have multiple. So there are no rules, in fact, and the formatting can change in the middle of the document as well. So that's why it's also sometimes important to consider local properties. So on a window of blocks around the current block, than global properties of the document in case there is a multi-document PDF. So just wanted to say this because enumeration, it's this concept in which we try to cluster the header together, the headers that follow the same styling, the headers that follow the same format. I think it's a robust approach. And also, I speak a little more about the metric because I think the metric should be more focused on finding the enumerations than finding the absolute depth, okay? The absolute level as an integer. So then to understand this kind of enumeration, so I built some features. And these features, for example, this could be the still feature equality between a paragraph and the neighbors. So on a window, for example, it's like a convolution. It's not very. I think it could be implemented if we had more data as a convolution. But be very careful because, in fact, it's only a few documents. So that means it means that we don't have so many different styles in a certain way, you know. So so the convolution will overfit. So that's why we need some simple features. By the way, all my work is about feature engineering. So still feature equality. So for example, if I want to, so I'm comparing, for example, if I am on a paragraph that is in bold, or the paragraphs, for example, -2, -1, +1, and +2. So the two paragraphs before and the two paragraphs after, are they in bold also? You know, if everything is in bold, then it's not very meaningful feature, the boldness. Okay. So this is what I call comparison, local comparison feature about style and about position also. so indentation and abscissa, and this is a way to start to understand enumerations, because enumerations will share some common styling features.
1 minute.
And is that okay?
1 minute left.
Okay. And another feature, another category of features, because there are not so many features, in fact, in my model. So it's about frequency analysis. So what needs to be done, understood also, is that the background versus the emphasis. If everything is in bold, boldness is not an interesting attribute. So I compute the frequency, for example, boldness in the document locally on a window of 20 blocks, or globally to the document on all paragraphs. How many blocks are in bold? If 100% are in bold, I will give that value. I will consider, for example, this paragraph. I'm not saying this paragraph is in bold. This paragraph has a boldness feature that is present 100% of the time in the document. So that means nothing. And if it says, okay, the boldness feature has a value that is only 2% of the time, it means probably it's an emphasis feature. Okay, it's different from the background information. It's also the case for enumeration. I will go a bit faster. So for header in-depth inference, so I'm using the frequency analysis features, the component feature, but I'm also using the font size, normalized, so the ratio with the font size with the most common font size in the document, to make it a bit invariant. I'm also using absolute features, so I've been trying multiple combination in an XGBoost model. So be careful. I think it's very interesting to have a validation dataset with documents that are different in styling, because otherwise it's going to overfit the style we have in the training dataset. So we cannot split the headers in train, tests, and val. It's not possible, because for example, 1/50 of the headers are all the same style. So it's a styling information that the model will overfit. So you cannot use it. It's better to use the validation dataset that we have. That's how I did it. And I'm using last function. I'm averaging the probability I get for header inference and depth inference. I'm averaging the values when it is a numbered enumeration, so then there is an explicit numbering. So 1, 2, 3, 4, 5 in the header enumeration. I will not take the value that is given predicted for this header, but the average value predicted for all headers in the enumerations.
Sorry, Christopher, I have to stop you there, but that's actually very, very interesting stuff. I mean, you've done a lot, and I think you could still do more, because it looks like you're very excited about this.
Yes.
I do like what you've done about having what you call the common kind of style, and then all the other features that you extracted to kind of like predict headers. So that's actually very intuitive. So there's a quick question for you before I move to the next speaker. So Dominique says, in your opinion, how key is, I don't know what Abby is. She says, how key is, I don't know. Dominique, I think I...
Sorry, yes, the ABI extractor. Hi, Christopher.
Hi.
How key is the ABI fine reader extractor regarding the feature extraction? Meaning, do you think you could do something as accurate with another extractor, such as PDF Miner or whatever?
Yes. The errors, there will be some errors. There will be some errors in reading order. So, and this has an impact on the metric. And there will be some errors also in the line extraction and the word extraction. Sometimes you have some errors in the, so it's not so easy to read a PDF.
Yeah.
So there is also an option in ABI to reuse the values when possible inside the PDF, because in fact you don't need really to do the character recognition, because in the PDF you have it. So I'm simply using ABI FineReader just for the layout analysis technology, because I have a lot of experience on it. I think it's possible to work on that subject as well, but we cannot work on everything at the same time. And it's surprising also to see that on layout analysis, we use technologies that do not use any machine learning. These are techniques invented 10 years ago. We could revisit them. I'm not sure it's very worth, but that's why I'm using ABI.
Okay, thank you.
Thanks a lot, both of you. Again, Christopher, congratulations. That is
Thank you.
Very interesting stuff. Well done.